Well, as you can see on the stage, we think of a great show coming, awaiting us. Well, it's a joint presentation. The last talk of the day is a joint presentation of the last two, in your program, the last two talks. They're going to present it jointly, right? So it's going to be a bit long, you know, more than an hour, 1.5 hours to 2 hours. Well, it's on security, past, present, and future. That's presented by the members of the Open Organization of Lockpickers of USA, the USA chapter, and presented by 3 members of the organization, Vivian Olam, Eric McCall, and Q. And in conjunction with that, you know, Mr. Tobias is going to also talk about high security locks. Those of you who have visited the lockpicking stall outside, you have noticed the setup here. So I believe they're going to show us lockpicking and its effect on security. So it's slightly different from all the talks we heard this morning. So without wasting any more time, let's give them a warm welcome.
Thanks very much. It's a pleasure to be here. We're switching our order this afternoon because we thought it might make a little more sense. My name is Marc Tobias. We're all obviously from America. I'll give about a 45-minute to an hour presentation on high security locks, and then I'll be followed by my associates from America and TOOOL USA, who will do some demonstrations, and they also, of course, were running Lockpicking Village all day today and I believe tomorrow. And so it's a pleasure to be here. This is my first trip to Malaysia. I've spent a lot of time in the Far East, but not Malaysia, and quite enjoyable so far. We're glad you're all here. This afternoon, I'm going to talk about high security locks, and there's a lot of material to cover, and it's all contained in a PowerPoint which will be posted on HITB's website and on our website, which is security.org and in.security.org. And so y'all are free to go grab the information, and I've got a lot of ground to cover. So today we're going to talk about conventional versus high security locks. We're going to talk about the standards by which these are tested. We're going to talk about bypass methods briefly, and then we're going to talk about the real problem, which is what manufacturers are telling you about the security of their lock, which may or may not be true. And then we're going to address certain liability issues. Everyone asks me, what is a lawyer doing picking locks? And much to the chagrin or disappointment of my parents, I've been doing that since I was 15 years old. When I was in college, I wrote the first edition of my textbook, and then 20 years later updated it. A lawyer is involved in security because all security is about liability, and liability is about lawyers. If there's no losses, if there's no injury, if there's no danger, there's no liability and there's no security issue. So locks are at the core of everything. They protect your IT infrastructure. They're your first line of defense, and that's why they're important and why you need to understand what's going on. Conventional pin tumbler locks. These have minimal security against covert methods of entry, and that's primarily what we're talking about today. Covert, surreptitious methods of entry. These locks can be bumped open easily. Bumping was introduced into Europe in a big way in 2004 by Barry Wells and Han Fei and all the rest of the guys up in the Netherlands and in Germany. In America in 2006, Barry Wells, Matt Fiddler, and myself really introduced bumping to the American public through the news media, through HOPE in New York and through DEF CON in Las Vegas. The problem, first of all, with conventional locks, there's no standards to test them. They're not supposed to be used in high security installations. And there's no secondary locking systems to make these locks more secure. All of the locks that y'all were bumping today at the TOOOL booth are conventional cylinders. But that isn't where it stops. So let's talk about high security locks, which is really what you want to be using to protect your infrastructure. What are they? Where are they used and why? And the standards, what do the standards mean by your rating organizations that actually define a lock as high security? So we're going to talk about what you need to know. So high security locks are used to protect critical infrastructure and high value targets. Where are they used? For example, nuclear bases, embassies, the White House, the Pentagon, all kinds of installations that need to be specially protected. So, what does the manufacturer know about their own locks? Well, in the last year, as I'll discuss, some manufacturers not a lot. Some think they know a lot and really don't about the ability to bypass their locks. So what exactly is a high security lock? First of all, they're expensive. They're sort of like an insurance policy against people breaking in. That's what they're supposed to do. High security locks are high tolerance devices. They use quality materials and workmanship. They are extended tested for security to make sure that you can't bypass their internal security. There's special distribution channels. You can't just go to any lock shop and generally buy high security locks. There's many security enhancements in these locks, and they generally have 2 or 3 different locking levels that all have to work simultaneously in order to open the lock. So why do you use high security locks? When you really need to be sure that your facility isn't going to be penetrated. High value targets, critical infrastructure. At the heart of every IT operation, there's physical hardware. That physical hardware needs to be protected. That's what you use: locks, access control, alarm systems, guards, video. But at the end of the day, the first thing we're talking about is locks. So we have high value businesses, banks, diamond facilities, narcotics storage facilities, government installations, critical targets. Why do we need them? Why do we specifically need high security locks? Because we need locks that are protected against some of the methods of bypass that were demonstrated today at the Lockpicking Village by TOOOL. Specifically, what are the threats? Bumping, picking, replication of keys, which is we call key control, and extrapolation of the top level master key. That means walking into a facility and being able to compromise the facility by obtaining one key that opens all the locks. All of those issues are supposedly built into high security locks. That's what you're paying the extra money for the protection. Standards. All high security locks are generally rated by standards organization. For example, in Germany, VDS. In the United States, Underwriters Laboratory and Builders Hardware Manufacturers Association. These organizations and others, British Standards Institute, there's standards institutes around the world that analyze locks to make sure that they're secure for a given amount of time and expertise to violate their security. High security lock standards. They're the benchmarks that you all rely on when you purchase locks for your facility. So the real question is, how are the locks tested and by whom? The standards, in my view and my associates' view, may be grossly inadequate in some respects to test locks against what we call real-world threats. As a matter of fact, next week in America, the Underwriters Laboratory, which is the primary testing organization in the United States, is addressing the threat of bumping. It only took them a couple years to get to it, but they've now figured out there's a problem. Most conventional pin tumbler locks that you folks are using can be opened in seconds by a child, literally. Last year in Las Vegas, I interviewed an 11-year-old girl that bumped open cylinders in a few seconds with no previous training, just as I watched some of you do today. And so this is a real problem. So So we're going to talk today about a case example that involves the most prestigious, most respected high security lock manufacturer in the United States who has world distribution channels everywhere, Medico. High security locks, primary protection criteria. There's 3 of them. These locks are designed to protect against forced entry, against covert entry, and to provide key control. What do we mean by key control? It's simple. So you can't take the keys from these locks and go to the local hardware store or go to the local locksmith and duplicate them. If you can duplicate the keys with no controls, then your system is not secure. So all of the high security lock manufacturers build in key control. So it's very difficult, or different levels of difficulty in replicating the keys. If you can't replicate the key, you have much more difficulty opening the lock. So what are we talking about? We're talking about bumping. We're talking about special forms of picking. We're talking about mechanical bypass, real-world techniques, and bypass of key control. All of these issues are not addressed in the standards. So when you install locks in your facilities, they may not be adequate to protect against what you need to protect against. For example, the UL Underwriters Laboratory in the United States, 437 is supposedly the high security lock standard. They rate a cylinder to resist entry techniques for 10 minutes covertly, and for forced entry techniques for 5 minutes. Some of the locks can be opened in much less time than that, which raises serious issues, because you folks in your jobs in security rely on these locks to protect your infrastructure. What are the security tests? Forced entry, for example, impact, tension, torque. There's all kinds of forced entry tests that are done to make sure these locks are secure. This, for example, is an end mill, a portable battery-operated end mill that can open most conventional locks in seconds. As you can see, this is called drilling or reaming. And all of these cylinders were opened in about 30 seconds by sticking this tool right into the front of the lock, drilling it out, sticking a screwdriver in, and opening it. That's one leg of the 3 levels of protection, forced entry. The kind of tools that these standards organizations use for testing are generally hand tools that you can carry in, not real sophisticated tools. High security standards, the other rating organization in the United States. Key control, and there's several levels of key control to protect your keys from others gaining access, others being able to copy the keys. And again, forced entry. So covert methods of entry, they usually test for picking and impressioning. The problem is they're not testing for other forms of covert entry. This is our real problem. These are different kinds of lock-picking tools that were shown at the TOOL exhibit at the TOOL booth. These are common standard lock-picking tools. Mechanical bypass. Most of these standards organizations are not adequately testing for mechanical bypass. What do we mean by that? That means defeating locks in less than a minute, maybe a minute and a half, maybe 30 seconds. Often not included in the standards. Many certified locks, many high security locks can be bypassed with mechanical techniques. This should not be occurring, and the problem is that all of you folks and your facilities are at risk because of this. Mechanical bypass, another method of entry. How do we do it? Wires and shims, little tiny wires, vibration, shock, bumping, air pressure, magnetism, breaking of internal components, radio frequency energy, for example, from a walkie-talkie, and temperature. Heat up the lock, freeze the lock. All of these techniques can open different kinds of locks. And there's a lot of testing that's not being done to protect you. Manufacturers, what they know and what they'll tell you. Medico locks, America, great R&D. They've spent millions of dollars developing their locks. Same thing with ASA Abloy, Multi-Lock, MIWA. There's many, many, many high security lock manufacturers in the world. Some of them have a poor understanding of methods of bypass. That's a real problem because you can't design a lock to be secure unless you know how to break that lock. That's a real problem. The case example that I'm going through with Medico in the United States, their engineers can't figure out how to open their own locks, so they say our locks are secure and they cannot be opened. That's a real problem because they don't know. And the real issue is what I call a failure of imagination. What does that mean? It means that sometimes a 15-year-old kid can figure out how to open a lock that all these genius design engineers that work for these lock companies, they can't figure it out. And this is a real problem because this translates into real-world vulnerability. Manufacturers may misrepresent their security. Either they know there's a problem and they won't tell you about it because it'll cost them a lot of money, or they don't know and they don't tell you. So what you need to know about high security locks, again, the manufacturers may not know or they may not tell you. The manufacturers may not fix a problem that they know about. The criminals may know about the exploit, they may exploit the problem, and the good guys, you folks, may not know about the problem until you walk in and all your servers are gone or your information is gone. Mechanical bypass is often simple. The Medico deadbolt. This is one of the best deadbolts in the world, bar none. It's an excellent piece of mechanical engineering. Unfortunately, this $2 screwdriver can open this deadbolt in about 30 seconds. We don't call that real security. I released a security alert on this on our site and on Engadget a few weeks ago. Medico hasn't responded yet. They said they were going to fix it. They haven't yet, possibly because they're not quite sure how to fix it. This defect has been around for 20 years. Nobody discovered it. We looked at this lock actually by accident. We were looking for some other things and we figured out how to break it. For 20 years, this has been sitting there, and so everybody that's got these deadbolts, single-sided Medico deadbolts, has a potential real problem. For 40 years, this same lock has been incapable of reliably and repeatedly being opened covertly. There are some experts in the world that have developed very special tools to open these locks. But it requires a lot of training, it's expensive, and it's not 100%. We sat down a year ago after Medico released their news report and press release that their locks were bump-proof. Bad choice of terms. Their locks aren't bump-proof. And now they're trying to rewrite history on the internet by changing their news release to indicate that they're virtually bump-proof. And then we've gone from virtually bump-proof to virtually resistant, which doesn't mean a lot. So they have a real problem. And all they have to do is fix it. They ought to tell everybody they have a problem and address it. What are they doing? They're telling everybody this is all a lie. This can't be happening. We can't replicate it. Just because they can't replicate it doesn't mean it's not happening. It just means that they ought to go watch the video that you're going to see of the 12-year-old girl that opened their lock in Las Vegas a few weeks ago. Maybe she could help them. So, representations by manufacturers. Their locks are secure, absolutely. There's implied representations. When you take a company like Medico, Abloy, Multi-Lock, Zeiss Icon, all of these companies are really, really good companies. The problem is they don't know sometimes. That's why they hire consultants sometimes to figure out their problems. But there's implied representations because they have expertise and they're representing to you folks that are relying on them that they actually know what they're doing. They also tell you their locks meet specifications. They may not be. We're also, in America, we're pushing for truth in packaging, so that if a lock has a vulnerability, or for example, can be bumped open, they need to tell you that when you buy a lock. They don't tell you about design issues and failures, and they may not know about certain bypass techniques. Again, it's a failure of imagination. Mechanical bypass, forced entry techniques, covert entry techniques, key control. There's a lot of times, design engineers I meet with around the world, there's a failure to understand laws of physics. There's a failure to understand methods of entry. There's a failure to imagine. So here's our classic case example. Do they know about their locks, or are they just incompetent? It's coming to that question. They continue to represent that their locks cannot be bumped open. I'm going to show you a video in a couple minutes. The 12-year-old girl and myself bumping open Medeco locks, bump-proof Medeco locks. They say their locks cannot be picked. Their locks can be picked. Now, are they easy to pick? It depends. If you just walk up to their locks, be it any of these high security lock manufacturers, no, they're not easy to pick at all. Well, not all of them aren't easy to pick at all. There are some manufacturers that can be easily picked, and they are high security locks if you have a $300 tool, for example. And so, is this real security? If somebody can get into your critical infrastructure in 2 minutes, does anybody here consider that that's real security? I don't think so. So, key control. Can your key control be bypassed? I'll show you another video that was in the articles I wrote on Engadget, showing how we simulated keys for Medeco locks and totally bypassed their key control. And this is very important if you have restricted or proprietary keyways. So the Medeco high security cylinder, it protects high value and critical targets all over the world. It's the leading US high security lock manufacturer. And frankly, I have nothing but respect for this company. I just think they have a little problem now and they ought to address it. And for 35 years, they have been the lock to attack. And most people, most experts have failed in those attacks. They're high security rated. Everyone trusts their security. It's the best engineering in the industry, which is a little frightening when you think that this deadbolt lock that protects really high security targets, 30 seconds with a $2 screwdriver. That's not security. So, more medical security. Many attacks during the last 35 years to try to open them. Difficult, complex, high skill level. They have a global presence. They have 2 or 3 separate parallel locking systems. You can't just open one of them. You got to open all 3 of them. Very, very secure unless you know the secret. Medeco invented the modern sidebar. That and everybody else has copied this. All the high security locks in the world that use pin tumbler technology, basically they all use sidebars, which is a secondary locking system that makes these locks almost impossible to open. Almost. So here's the problem. Medeco, like other companies, have been caught up what I believe in their own arrogance. They think they're smarter than anybody else regarding their products. They should be. Absolutely. But they don't really take input, and not on this critical issue. Nobody could know as much as they do. So the real problem is their engineers have an inability to test their own locks to protect you. So again, I want to make sure everybody understands. They're a very high quality lock manufacturer. They got great products. For 90 to 95% of the usage, they're just fine. The problem is critical infrastructure, high value targets. Then you need to understand the vulnerabilities. So how did we do this? It all began with bumping, a chronology of events. Myself and Barry Wells from the Netherlands, the guy that really brought bumping to Europe in 2004, we introduced in New York at 2600 at Hope, bumping to the United States. Then myself and my associate Matt Fiddler at DEF CON 14 last year had little Jenna Lynn, the 11-year-old, start bumping open locks. She became an instant star. On August 4th, Medico issued a press release. Our locks are bump-proof, because they figured this was a marketing bonanza. And they were probably right. At that point, I called their director of technology, and I suggested to him that maybe they shouldn't be using that language, because maybe their locks weren't bump-proof, because myself and my associate, Tobias Bluesmanis, who's a 20-year-plus locksmith in Miami and expert in Medico, began a year-long research project to prove Medico wrong. Originally, we started off with the question, can the locks be bumped? And of course, Medico said, absolutely not. That's why we wrote the press release. So, it resulted in a wider inquiry. We developed a reliable method of picking, and I'm talking about a method of picking a high percentage of their cylinders in 1, 2, 3 minutes. For high security locks, this is not tolerable and it doesn't meet the standard. Then in October, I met with their company and their chief technical director, and I showed him what we could do. This was in the early stages of our research. So they handed me 2 cylinders off the factory floor, and the keys that we developed wouldn't open them. Now, subsequently, about 24 hours later, when I got home from my trip, I opened them and offered to send the locks. Did they want them? No. They had the mindset, this couldn't be done. So then, what I call Miami Vice. In December, I went down to Miami. We basically really tweaked our research, and we created a video, and we're going to show you a couple clips, how we could bump open and pick open their locks. We sent the video and all the documentation to Medico. Since then, they're not talking. We perfected the ability to open these and other high security locks. And I should mention, after my talk, these guys are going to talk, and then we're going to demonstrate, and especially for the government folks that are here in a sidebar, what the problem is and what the vulnerabilities are. So we do hope you'll stick around. So we perfected the ability to open their locks. 4 keys to the kingdom. We've developed the technology, we believe, with 4 keys to simulate all the codes to open all the non-master keyed cylinders that this company produces, assuming you have the right keyway. There are some caveats. You just can't walk up to their locks with these 4 keys unless they're the right keyway, so they'll actually go into the lock. But theoretically, and as Medico would say, we can virtually open all of their locks. Because if the word virtual is good for them, it's good for us. Yes, indeed. So, bumping to picking to bypass of key control. We expanded our research. We developed a method to pick their new M3 lock. This is their latest and greatest that extended their patent another 20 years that came out in 2005. We also developed a technique to determine the real security of these locks, which is called the sidebar coding. Medico security, there's 3 levels. The pin tumblers lift, the pin tumblers rotate, and then there's a little slider that moves back and forth. All 3 occurrences have to be simultaneous to open their locks. So Medico methodology, how did we do this? We compromised the control. We determined and simulated the sidebar codes. We bypassed the M3 slider. We determined how to make a bump key, and then we developed a reliable means of picking. How did we bypass their key control? Well, we figured out that they widened the keyway by 7/1000ths of an inch in their new lock. 7/1000ths of an inch in a high security lock is a lot of movement. It's a lot of space. We're talking about locks that have tolerances of 1 or 2/1000ths of an inch. So 7/1000ths of an inch was pretty relevant to us. And so we first figured out how to make keys to bypass all their keyways, and then we figured out how to take that technology and make a bump key. That's a real problem, because especially in government installations, they have proprietary keyways that you're not supposed to be able to get the blanks to duplicate the keys. So what we did, we create our own blanks. Not difficult. And then we made keys to open the locks on those simulated blanks. Sidebar codes. The heart of the security in this system is what we call a sidebar code. It's a combination of angles, and I think I've got a photograph of the keys. The trick with Medico and why they're so incredibly popular and secure around the world is that all the cuts on the keys are at different angles. And so the composite of angles have to be correct or you can't open the lock. So if you don't have the sidebar code, these locks are 100% secure. So what we figured out how to do was simulate the sidebar codes. How did we do that? We took their code book and computerized the data, and then we did an extensive analysis. And we figured out, again, how to make 4 keys that would virtually open all of their locks. That's a problem. All of their non-master keyed cylinders. So what we've done is we've compromised all of the levels of their security. What does this mean to everybody that uses their locks? And we've not only done this with their locks, we've done similar issues with other high security locks that are very, very popular. One of which is sold in this country, multi-lock. I went to a locksmith at your Mid-Valley Mall. They sell Abloy, which are very good locks, and they sell multi-lock. Those are good locks. They're great locks, except that they can be opened very rapidly, and they can be bumped open. And the manufacturer keeps saying this is smoke and mirrors. That's a problem, because everybody's relying on this security. So the latest technology, as I said at Medico, is the M3. And I'm talking about Medico because this is a classic case example. And I really like this company. They got great engineering. It's a phenomenal success story in the United States. Their locks are used everywhere in the world. And so it's a great story because other manufacturers should understand what can go wrong. And this has really gone wrong. So the Medico sidebar codes, this is a Medico key. And that was, okay, still got a mic. Oh, we're still in one piece. And this is a picture of their key. And as you can see, these are at different angles. That's the secret. So you have to not only lift the tumblers, but you have to twist the tumblers. So that's what we figured out how to do with our special 4 keys. I don't know what that is. No, I don't think so. You guys have a mic?
Nothing.
Okay, Eric, I knew you did it.
You got me. You got me.
Okay, so at any rate, the common myths, key control. You need to understand that every mechanical key can be replicated. Frankly, there's only one key that I would trust not to be replicated in the world right now, and that's the magnetic code system made by Eva Locks in Vienna, Austria. Now, in all fairness, I do consulting work for Eva. I have the highest respect for this company. They're the largest lock manufacturer in Austria. Their keys for this system cannot be replicated because they have embedded rare earth magnets in the keys. So that introduces something that cannot be copied with silicone or other impressioning techniques. The rest of the mechanical keys, most of them really have a problem because you can copy them. So, then comes the Michaud attack. It's like the Mars attack. Last year, 2 years ago, last year, Eric went to Medico. He had found something that we had found also a couple years ago, but we didn't at that point think it had much application. So Eric goes to Medico and says, I think you have a problem. I think you can bypass your slider technology, your newest, greatest technology with a piece of wire. Medico basically doesn't understand the problem. They ignore it, and it really, at that point, doesn't have much significance because just bypassing one component of this cylinder doesn't open, doesn't mean a thing. Well, it means something now because as you see in the slide, we took Eric's idea and frankly, we came up with it at the same time. In fact, I talked to Eric about it and said, well, so what? This was a year and a half, maybe 2 years ago. And we kind of ignored the problem because we didn't have the rest of the puzzle solved. Now we have the rest of the puzzle solved, and what we can tell you, this is great. We bypassed this level of security with a paper clip. This cylinder with a paper clip stuck in it that totally bypasses one of 3 layers of security.
This is the standard Medico M3 key. It's distinctive, as you'll note, because there's a protrusion on the right-hand side of the key. When this key slides into the lock, the protrusion interfaces with a sliding mechanism within the lock unless the sidebar and the slider are in the correct position, the lock cannot be opened. This is a standard Medico M3 6-pin cylinder. This is a high security rated UL 437 and ANSI 156.30 certified cylinder. That means that it is designed to resist covert methods of attack for at least 10 or 15 minutes depending upon the standard. This lock has a piece of wire inserted into the keyway in order to circumvent the action of the slider. Just doing this will not open the lock. This is a simulated key that we have created to open this Medico M3 cylinder. This key will open the lock. The key is inserted. The lock is open, just as if it were a factory standard key. The slider is completely bypassed. It's just that simple. The other problem is that other types of keys can be simulated for these locks, including the potential for bump keys.
That is a problem. So, common myth number 2, bumping. Some high security locks can be bumped open. Medico, ASA, Multilock, just to name a few. The manufacturers say it can't happen. The manufacturers don't understand the problem. So, Medico, not bump proof. Our locks are bump proof. Our locks are virtually bump proof. Our locks are virtually resistant. Virtually bump proof equals virtual reality. We couldn't help ourselves.
So what did you do?
So what I did was I bumped this lock by putting the key inside, and you then put just a little tension, and then you hit it with the hammer, and then it took me a few times before the key actually turned and it opened.
And how many times did you do it?
I wasn't counting.
Are you willing to give it another try on camera?
She probably won't be able to do it because she's nervous.
It's up
She
to
can
you.
try it. You can try it. Go ahead and try it. Oh, you want your bump hammer? Okay.
Special.
Okay. There it's open.
Wow. There you have more video proof of it.
And that is, now there's a number 2, oh, you turned it, you locked it. There's a number 2 on this that we've identified the cylinder. This is going to be sent for analysis tomorrow to another expert. And, but you saw it.
Oh, it's saw it right on video.
Right on video.
This is a 12-year-old girl. This is a 12-year-old girl that opened a bump-proof lock. Now, this is a very talented little girl, but she's still 12 years old and not that talented, and she never touched a lock before last year. So next.
Can you get it? Okay, so this is the double cut keys that bumped open this lock with one ARX pin in it. And as you can see, our paper clip is bypassing the slider. And as you can see, this isn't opening this lock. So, of course, we won't be able to bump this open now.
This was sent to Mexico as part of our package from Miami Vice.
Naturally, we won't be able to do this now. Well, see, it was easy the first time I did it. There you go. Your lock is bumped open. This is with an ARX pin. I'll send this to you. So, that's not too bad. That's one ARX pin in the 6th position. So, let's do this one more time. Zoom in just a little bit closer. And again, so that you don't think this is a put-up deal, there's the key that bumped open that lock with the ARX pin. Okay? Okay, you track the camera with me, okay? There you go. 2 whacks and it's open. Now you can say that now that we're wearing this lock, it's easier to open. 2 whacks, 10 seconds.
It's
ARX pin. Okay?
2 whacks. It's perfect for the Sopranos. And let me explain. ARX pins, which you see here, turn on the lights a little bit. This is a very, very, very special pin that Medico employs in their highest security installations for government entities. This pin was developed to make all of the known attacks on their cylinders, picking attacks, impossible. And it really does that. And so before I went down to Miami, I asked my contact at Medico to send me the latest version of their ARX pins. Okay, and they usually put 1 or 2 of these in a cylinder where they really, really, really have to be sure. And so they sent me several of these pins. I went to Miami. We really weren't expecting to bump these open or to pick them open. We really believed it was impossible, but this whole road that we took for the year of research was quite eye-opening as to what we should expect and how we keep our minds open. Again, it's imagination. We figured out how to bump open a lock with one of these pins. Now, in all fairness, there's 3 different levels of these pins. We bumped open 1 level. When I called my contact at Medico that Sunday afternoon from Miami, as I'm sitting there bumping this lock open, I said, well, we've bumped open your lock and we've picked it with an ARX pin. And my guy says, no, no, no. That is impossible. That must be a defective pin. I said, the defective pin? You just Federal Expressed it to me 2 days ago. How can a pin be defective? He says, no, no, no. There has to be something wrong. Or the lock is defective. I said, the lock is defective? A Medico lock that's brand new right out of the package that we just took off the shelf is defective? He says, look, something's terribly, terribly wrong because you can't do this. I said, right, okay, we'll send you the lock, we'll send you the key, we'll send you the video. We did that. I haven't heard since. We have no comment. So, And we also figured out how to pick their locks. So there's been really high-tech decoders and pick systems developed for Medico. All of them are very high-tech, very difficult, take a lot of training. Ours, the way we do it, can take 1 minute. 1 minute. Now, that's not all their locks. It's just virtually all their locks. Okay, so I'm sure they're going to be real sick of that term virtual by the time this is over. So here's the example of picking. This is real. This has not been edited. We took the slice out.
Oh, you did pick the slide,
This was
right?
also sent to Medico. And this is a cutaway that we did of the M3 to show out what it looks like. This is real world. This is the bad guys entering your bank or your government facility.
Right, right. Yeah, right.
And we did not edit this so
Right.
Medico would understand this is real world. Whatever it was is what it was. So the real trick here, these are conventional picks that are opening this lock. These aren't
Too much, huh?
special tools. As you can see, it's just a standard curve pick. This is impossible. This is unheard of,
Okay.
this kind of lock.
Now, that
It's
took a little
open.
longer than I would expect a Medico to take to open, but you got it. Okay, and show the key that opens this lock normally. Okay, so we can see we have a normal open,
We're gonna do it again even
M3.
faster.
Now, and it shouldn't really matter once you release the torque, once that code is set and we haven't disturbed it. So what we're doing is we're locking the pins in position by applying torque.
Now, in all fairness, my associate in this is very good at picking locks. I think I used to be that good, but I don't pick that many locks anymore. I teach it, but I don't have to pick them. It took me about 3 minutes to open this lock.
Who is that with you there?
No, it was Tobias Bluesmanis, my partner on this down in Miami. Now,
Right.
this may look simple.
And you're sure you've set the...
It's not really that simple.
Okay, that's not too
It's
bad
open.
as far as opening a UL 437 lock. And put the key right in front of it again, okay?
This is the best we have in America. That's a little scary, isn't it? Hardware bypass. This is the last demo we're going to show you. And again, I'd be glad to talk to you folks after our PowerPoint presentations to show you how this works. So the icing on the cake, the deadbolt. You got to remember when you're designing locks that the key never unlocks the lock. Now that may not seem logical, but that's the truth. So this deadbolt design has been around for 20 years. We figured out how to bypass, as I said, in 30 seconds with a $2 screwdriver. Here's one of their deadbolts, as I showed you, and here's the screwdriver. Now, in all fairness, we've omitted about 30 seconds of video because I don't need to cause a problem worldwide before they fix this. I want to alert everybody that if you're using these locks, you need to talk to your locksmith or security consultant because they're not secure. They bypass all the internal mechanisms that prevent them or virtually prevent them from being picked, from being bumped, from being bypassed. You have to understand this is a mechanical bypass. This is a $2 screwdriver from the hardware store.
This is a 5-pin Medico M3. Show this lock is working correctly.
This is
You can see that the deadbolt retracts and extends with ease. We can lock it We can unlock it.
That's a
That's the end
screwdriver.
of the story.
Oh, now don't be laughing. Yeah, let's hear a hand for Mr. Medico. So, liability, defective or deficient products, negligent design, misrepresentations in packaging. The manufacturers are supposed to be experts. There's certain federal statutes involved and there's case law involved. So what do we need to solve this problem? We need real world testing. We need laboratories that are looking for these problems, and frankly, that's been my mission, to push the standards organizations to educate them. They need to change their standards, and the manufacturers need to start bringing certain people into the loop that can help them find their own problems. My email address is mwtobias@security.org. My website is security.org. My blog is in.security.org, how apropos. Feel free to write me or get a hold of me if you have any questions. Does anybody have any questions before I turn it over to these guys? No questions? Yeah.
Hello. You said that your background from a lawyer. So what is the legal recourse for customers when they buy lots that has all these problems? What is their actually legal recourse in this case?
What's their legal rights?
No, legal recourse. I mean, it's like I'm a customer. I found out that the medical lots all have these problems. Like the last slide that you showed, that a little screwdriver like this. What can a customer like me do when I find out if the manufacturer misrepresent,
Well, that's a really good question that Medico and all these other manufacturers are going to have to wrestle with. That's a really good question, because my view is if you bought one of these cylinders, for example, they need to fix it or replace it. Now, I don't know what the time frame is, and there may be millions of these out there. I don't know the number. I know they're very, very popular. It's going to be very, very expensive for them to deal with this. And there's other manufacturers that we're dealing with right now also with these kind of issues. It's going to be very expensive, and at the end of the day, it's not going to be a good deal. Other questions? God did such a great job. Nobody else got any questions? Yep. No? Okay. I'll turn it over to you guys now. Sorry. Go ahead.
We want to do Q&A at the end because we have a lot to cover. So, do this, but any other questions, we're going to do a big one at the end, and then we have the table.
Yeah, I think that'd be a better idea. No, I haven't yet. Frankly, I'm surprised they haven't contacted me. There's too many of them. Let me just tell you a 2-second story. I dealt with Munich Reinsurance years ago. They're like Lloyd's of London. They're out of Munich. They're one of the largest reinsurance companies in the world. I posed this issue to them. Why don't you guys do your own standards? Why don't you write your own requirements? You know what their answer was? We need the burglaries. We need the high profile cases in order to sell insurance policies to get more premiums. If there's no risk, nobody will buy insurance. Yeah, it's great. All right, let me turn it over to these guys. Which is the best question?
We'll probably know that at the end.
I think we'll know that at the end. We'll wait. Let me take 2 minutes. We'll boot up you guys' PowerPoint. Okay.
It's actually the HTML.
Oh, it's the HTML one. Okay. Very, very high tech. Okay, so we want to go to...
Oh, I see now.
Yeah, right. You got it. Okay, it's yours.
Close the little yellow warning.
I don't know that I can do that.
No, lower.
Switch over to the camera as need be from time to time. Welcome, I'm Deviant. I'm really happy to be here with the rest of the guys. We have so much fun talking about this. I can't thank you enough for the invite. How many of you were over talking to us earlier today at the Village? How many people had fun over at the Village? Thank you. Thank you for coming out. Marc did a wonderful summary of some of the high-end security locks that are out there and the ways that they are vulnerable. Now, I'm going to summarize for you how really vulnerable some of the low-end security is and why you shouldn't be using it. Very briefly, for anyone who doesn't yet know, let's talk about how keys open locks. Did we click that? There we go. We're going to have that the whole time? Great. Okay. How keys open locks and how lock pickers open locks. What's actually going on inside of the lock when someone's picking. Are we all right? Firefox, people. Oh, can we run that in Firefox? All right, we're fine. Normally when you look at a lock, a very conventional lock, this is what you see. You can see the round plug, the part that turns during the lock's operation. It's situated in a larger housing. And if you look down in that keyway, you can often see sticking down there the protrusion of a pin, because most locks are based on pin tumblers. This is what's actually happening inside of the lock. It's not a single pin, it's actually 2 pins in a stack, and they operate as follows. If you try to turn this plug right now with no key in the lock, it's not going to let you turn. Obviously, that top pin has dropped down and it's preventing the turn. It's only if a key is inserted, don't even worry about the bar, I don't care. It's only if a key is inserted, raising the pin stack to the appropriate height, that the lock is going to let the plug turn. Now, when you describe this to someone, they say, oh, that sounds pretty understandable. Are you with me so far? All right. Of course, it's not just a single pin stack in a lock. That would be very easy to defeat. It's a whole row of pin stacks. Usually, not always, but usually, the higher end, more expensive the lock, the more pins you have. They all line up, and it's multiple stacks working together. And only if a key is inserted with the right cut depth, or as it's called, the right bitting, do all of those shear lines meet in a row, allowing the plug to turn. And when you describe this, people think, well, I can picture that. Looking down on it on the top, on the left, you can see, well, that must be, chambers are drilled into the lock in a nice line, and all the pins line up, and you can sort of see this jiggling. Is imagine if someone's trying to turn the plug, well, those pins must all be hitting at the same time. And it's easy to picture it that way, but that's not really what happens in the real world. As we all know, there are tolerances of manufacturing. There are imperfections, less than perfect processes in a manufacturing plant. In reality, the pin chambers are hardly ever in perfect or even near perfect alignment. The cheaper a lock is, the more misaligned those chambers are. This is a slight exaggeration for our edification here, but some of them are almost this bad. And as you can see on the right in our animation, it's really only one pin stack that's ever actually binding because of that misalignment. It varies from lock to lock how the misalignment occurs, but you're never really getting the whole row of pins protecting you. This is what makes picking possible. You can do what is called setting pins. Here we have a lock. We put a little pressure on that plug, causes it to bind, but if you reach in with a tool and lift, you see that? You can lift the pin stack to the proper height. Once it reaches the height where it's supposed to be, the height where a key would have lifted it, that plug will actually turn a little bit. It'll even hang up on a lip. It'll hang up on the plug lip, that top pin. The top pin will never drop down again, and now the lock is being prevented from turning by the next misaligned pin. And if you lift that one, and then another one, and another, eventually, keeping the pins up on the lip, you can reach in. This is, a little wrench tool goes in, and here we're pushing. Now these pin stacks are loose, they're not binding, but here there's a click. That pin was binding. You could feel it. You can actually feel the pressure. And we push, click again. And this whole time the plug is clicking a little more, and before you know it, it all pops open. This is not complicated stuff. This is very, very easy. We'd love to try to do a demonstration of this for you now. And if you all cross your fingers, I think, can we switch to video from here? Almost. Maybe. Do we have anything? Ah, there we go. So right down here is what we want to be focusing on. Here is very conventional padlock. Nothing particularly, horrible about it. It's certainly not a high security level. Well, I mean, it's pretty horrible. We beat up on Master a lot because while they can make the occasional decent product, and they're really doing some nice research now, they really are champions of the cheap lock that everyone buys right off the shelf. So this is my wrench tool. Simply insert it into the lock. Not a lot of tension needed. Notice I'm not wrenching this down with my hand. I'm just resting it in my hand. We have an assortment of pick tools here. I'm going to reach for a short hook. If I insert this into the lock, not a lot of movement needed. Very slight, subtle clicks, and I can feel it clicking. This lock is open. But yeah, conventional picking, very, very simple. How many people picked a lock with us today in the village? See, look around, there are some hands. How many of those people had never picked a lock before? Almost all the same hands. It was not as hard as you thought it was, wasn't it? And wasn't it fun? It's really fun, and I encourage a lot of you to continue trying this with us.
Yeah, come right after. If not, tomorrow.
All right, can we click ahead again? Let's talk about some more bad security. How many people have ever seen a lock like this? Yep, show of hands, good. These locks are everywhere in the United States, at least where we're from. Do you have these locks a lot in Europe or in Asia? Or do you have something better? Hopefully you have something better. I will tell you why. These locks provide no real security. What we like to say is that if you're using one of these to secure your belongings, you're essentially doing this. You're essentially saying, please don't touch my things. This lock right here, if all goes well, I would like to open for you with a beer can. Shall we try this? You on camera? All right. This is simple aluminum metal, and I'm going to cut it a bit.
This is almost like Targus.
Yeah. And I'm going to take a strip about, I'll say, 2 centimeters by 5 centimeters. We like to say about 1 inch by maybe 2.5 inches. And with a couple of special cuts, I am going to try to improvise a device that you can purchase from a lock tool distributor. Why purchase when you can make your own? So here we have our little piece of metal. I'm just going to fold it up and shape it into the right size. It's a real quick and dirty job. It's a real ugly kind of a hack here, but hopefully, here's our lock, which is locked. Now there's a very good chance this won't work because these are pretty beat up, these locks. But let's see if we can get some satisfaction here. That damaged this is called a shim, by the way. That damaged this pretty badly. Don't think I'd be able to use it again. But only one try, as you can see, is all we needed. Okay, back to our slides. Almost. All right, so yes, you can see behind me, these are store-bought shims. You can see they're very similar to what we just crafted out of metal. You can purchase these online, they're very cheap, or you can, make your own. Either way, don't trust a lock of this design. Most locks, when you find out that can be shimmed or bypassed in certain ways, it's because they are relying on springs or spring pressure where they shouldn't be. There are locks that are not shimmable. They're high security padlocks. We can tell you about them later. Speaking about things later, there's a lot that we'd love to cover, but we simply don't have the time right now. Warded locks, wafer locks, we were playing with those in the village earlier. tubular locks. Is the gentleman who had the laptop with the lock stuck in it, is he here? Yes. We had a tubular lock conundrum that we were happy to try to address. Ask us of that in the village, mastering systems, a whole lot of other technologies. It's our pleasure to tell you about them, but I don't want to take up all the time right now. What we will cover, though, is, for anyone who hasn't seen it yet, is bumping. Marc just talked about bumping. It's really something that's hit the news a lot, and we want you to understand why it functions the way it does, why it's such a threat, and how certain manufacturers are trying to get their hands around this and address it. Essentially, we can explain bumping by talking about our high school physics classes. Everyone remembers Newtonian physics. If I fire this cue ball, what's going to move up here? Shout it out. The tube, exactly. If I click, I'm sorry, if I shoot that cue, the 3 stays stationary, the 2 keeps moving. This is what happens inside of a lock when a locksmith would use what's called a pick gun. A pick gun is a big spring-loaded piece of machinery that he sticks a blade down in there, and it smacks the pins, and the idea is to create a gap. As you saw earlier, we were lifting those, instead of lifting the pins with a tool, you just create a big gap and try to spin the plug when the gap is exposed. It's very effective, but pick guns are expensive. No one carries them around if they don't have a purpose for them. They also take a little while to get good with. You have to hold the blade at just the right angle. It has to smack just at the right time. You can do this even more easily with a bump key. Well, what is a bump key? A bump key is just a key designed to fit in the lock. It doesn't have to open it. It just has to be the same keyway, usually the same manufacturer, designed to fit in the lock that's been cut a special way. Every manufacturer has cut depths that are numbered. So every manufacturer, 0 is no cut, 1, 2, 3, 4, 5. They have a standard, and 9 is the deepest cut that any bidding level can ever have. Well, you can see here, we're showing a key that's cut all to the 9 level. So it just leaves a very low series of ridges. You can do this professionally with a key machine, or you can grind them by hand. Either way, if you stick that in the lock and then whack on it, this is the bump. Do you see that? Do you see it's touching every bottom pin exactly where it needs the force delivered without all the muss and fuss of a big pick gun? It is a beautiful way of delivering force right where it needs to be. Now, it's not beautiful on the pins or on the keys. How many people saw us breaking some locks out there, snapping keys apart? It is very rough. In fact, this technique has even been improved upon further to make things a little bit more subtle for the lock. Some people are even taking bump keys now and actually at the tip and the shoulder, cutting them down even further. They're trimming off about 0.5 millimeter of material from the key. They're actually trimming that shoulder down, trimming the tip down, and they're creating a very heavily modified key. Now, this is an even more elegant method of bumping. What you have now is a key. You can see this is that same bump key, but instead of leaving it hanging out of the lock and smacking on it, people can insert it all the way into the lock and even squeeze it a little further. You see that wiggle? The springs on the top are sort of kicking the key back out. But this is just enough action, just enough movement to still deliver the force you need to deliver without raking across all the pins and smashing things to kingdom come. They've designed some very nice tools now. People call them the tomahawk tool. You saw Jenna Lynn using my tomahawk in her video. It's a perfect way of delivering the force right where it needs to be. Bang, smacks that lock open. We'd love to try that on camera for you. How many people tried this for the first time in the Lockpick Village? And you got it to work, right? Wasn't it amazingly easy once you got it to work? Here is a key. I wonder if can we see that? See that ridge structure? This is essentially the cheapest, kind of crummy lock that is designed in our country. It's made by a company called Kwikset. Here it is in the lock. You can even see it kind of springs into the lock, springs out a little bit. Here's our tomahawk, and if we're lucky, there we go. This lock is now. It's not very difficult. large number of these locks are very susceptible. It's also, as we said, it's very unsophisticated. If an 11 or 12-year-old is doing this, that's not a person with specialized skill and training. That's something you really have to be concerned about. Another factor, it's very hard to track bumping. While you've seen, if you've been over there firsthand, you've seen the abuse these locks can take. They definitely can show wear and tear, but if you can bump a lock with 1 or 2 hits, you're not going to leave a lot of forensic evidence on that lock. If something is picked open, the key will actually, the pick tools will actually leave microscopic scratches in places that a key could never get. So a forensic scientist can actually go in later and say, well, look, obviously we've disassembled this, but we're looking in with a scope. This lock had something stuck in it that should not have been there. There's something amiss. A bump key, because it is a key, really does not touch the lock in a lot of improper ways. It doesn't actually leave scrapes and scratches where a key would not normally reach. So we think that there have been many cases possibly where locks could have been bumped open, but maybe an underwriter or an insurer has said, well, look, there's no evidence. We just assume you didn't properly control your keys. Maybe that was somebody who had a duplicate and you didn't know about it, or we're not going to pay this insurance claim. So again, very severe for a lot of reasons. How can we come up with some countermeasures? Well, some vendors and some really good thinkers have put their heads to this, and there's a few tactics that are coming out now that we have some degree of promise, we think. Still with me? All right. First of all, there's trap pinning. Trap pins work, as you can sort of see here. It's a conventional pin stack, but on either side, very high spring pressure, very high, jagged shaped pins are loaded in special chambers. Now with a normal key operation, the key is sort of supportive of that red bottom pin, and there's nothing wrong. It's just, the trap pins will just ride along on top. But if that lock is opened without a key, let's say by bumping, it creates a gap. That trap pin can fire down and actually seize the lock in place. Not only does it prevent someone from getting in with a bump attack, it will render the lock permanently stuck that way, leaving a direct evidence later on. You come in on Monday and say, wow, my lock's all jammed up. Someone was here over the weekend doing something they shouldn't have been doing. Problem with that is, well, there's really only one way to get the lock out of the door at that point, is to drill it apart. And locksmiths probably love that. They say, you got to invest in this lock. It's got trap pins. And if you ever have a problem, I'll come and install a new one. Another technique that is a little more elegant than that, not quite as horrible in terms of locking the lock forever, is called shallow drilling. Shallow drilling works as follows. Essentially, remember we were talking about those chambers that are drilled, often with imperfections that are hard to control? Well, this is conventional drilling of those chambers, and the pins can be dropped in later. With shallow drilling, one chamber is not drilled to full depth. So here we have the manufacturer making the lock, and see that one chamber that was left not fully drilled? Now, when a pin stack is loaded up, it will not be easily bumped, because as you can see, one pin doesn't hang down all the way. This will frustrate bumping attempts. One thing it'll also frustrate, however, is the ability of locksmiths or other security experts to key this lock to all its potential combinations. You can see that one chamber is not fully within the standard. You can't have every bitting cut in that chamber. Therefore, it can be a nightmare if you're trying to manage a whole huge array of locks. Something that takes this sort of physical approach to a better level that Marc touched on is something that the engineers at Master, of all companies, are experimenting with. A really nice technique that I call top gapping replicates this idea of completely taking the physics out of the equation of bumping, but it does so in a way that does not violate standard. This is a technique whereby the top pins are tapered, and because of this, they don't drop all the way into the chambers. They still, you can see, they're still up in the key, they're up in the shear line, they're preventing that lock from opening, but they don't drop down and touch the bottom pins. Now, you can just picture this. I don't think I have an animation, but if you try to bump this lock, especially when you consider spring pressure on top of those top pins, nothing's going to happen except for the bottom pins jumping, smashing, and falling down. This is a real nice idea. I'm very pleased with where this is going. This could be something that could really save the just simple the pin tumbler lock. Bumping, you never want to predict the end of an era, but bumping could have been the death knell of the conventional lock. It was just such a horrible, horrible risk. This is a technique that could be retrofitted depending on how they engineer it and how they mill the pins. It could really be the big save that people are hoping someone's going to design. So to wrap up, what locks employ these countermeasures to bumping? Not too many. Michel and Colin, Carl Edward Schulte, those are two European manufacturers that have tried some things. As I say, the only American company is Masterlock, who's coming up, but yet their solution is the most elegant, in my opinion. Maybe we'll see more of that. I sure hope we do soon. Remember, we've had a lot of fun talking about, entry that's really surreptitious and fun and intricate, but in the real world, don't lose sight of the fact that a lot of your entry that's access entry that shouldn't be granted is going to be granted by someone who's brute forcing their way in. Keep that in mind. Don't, put the $100 lock in the $10 door. Don't have your server room. Someone once said, I have this lock on my server room that would take an hour to get picked. And I said, that's great. I've been to your office, man. Your server's in a basement, and it's in a hallway where no one ever goes, and you don't have any cameras. I could stand in your basement for an hour, and no one would bother me. That's a whole other problem you've got to deal with first. What good is keeping logs on your firewall if you never run them through an IDS and never check them? What good is a high security lock if it's somewhere that a person could conceivably be for hours at a time without being disturbed? Keep that in mind, please. To wrap up, what is a good lock? Do we have any recommendations? Every one of us, we have our favorites. Even though, I might have to take Medico out of that list soon, for the way you've been attacking them so much, my friend.
No, they're a great lock.
Yeah, they really are.
Application.
Yeah, I still love them. The design is a real nice design. Other than that, a lot of my friends have a scorpion lock in their doors. It's a slider-based lock. If you're in charge of your large facilities, consider looking at Best. They make an SFIC, interchangeable core. Abbas, of course, Abbas and Alloy, terrific locks. How many people saw the rotating disc over in the Village? Beautiful system. That big padlock you see right there is a Sargent and Greenleaf. If you're from the West, over in the States, those are military locks. They're armory grade locks that you can sometimes get used. Overall, you're going to get what you pay for. If you're paying for a cheap lock, there's a reason for it. Hopefully, with the work that Marc and some others are doing in research, we'd like to say if you're paying for the expensive lock, you should be getting what you deserve there. I could wrap it up. I could turn it to you. I have a quick story, but maybe we'll save I'll show you about a bypass story at the end if we have some time. Thank you. Just minimize that, because I might come back to it.
Wow, it's so silent out there. Come on, how we doing? No? Yeah, all right. Because, we don't have to stay here. We can just do something else, but all right. All right, here it was, all right.
About some very tricky, high-end awesomeness. Is his mic on?
Is it on?
Yeah, there you go.
All right, sorry about that. Today I'm going to be talking about a few things. The first thing is going to be just an introduction on kind of the transition from mechanical to electronic-based locks. I'm kind of like the black sheep of the group, the only one doing like electronics works, while the rest of them stay on the physical side. So we're going to go through a few history lessons in that regard. So then I'm going to hit on two major technologies that are pretty prevalent today. One's going to be RFID, which I'm sure you're all pretty familiar with, and the second going to be biometrics. So let's start. Mechanical versus electronic. I say primary and secondary with according to these because it's kind of like mechanical has always been the primary base lock. It's the physical barrier that's, first defense against guarding, your houses, your buildings, your work office, cars, things we see pretty much today. And secondary, what we have is coming in the last, 5 or 6 years will be electronic systems. Things like RFID, biometrics, smart cards. These things are like a secondary technology that are not only protecting, but they're also kind of like user access control. They assist in the security of the primary lock. So what we're doing is we're adding a layer of security that we must analyze when we use the electronic locks on top of the mechanical. The interaction, we have to really determine whether it's cost efficient. Like, is there really necessary to have 4 or 5 lines of defense in something that really is trivial, or the value really isn't there? So, history of early electronic systems. This one kind of intrigued me because it's a World War II IFF system. I'm not sure if anyone has heard of this, but it's kind of like it's a system that regards closely to RFID. It's interaction friend or identification friend or foe. What it does is it's kind of like ground control will okay, so my time. Okay. I'm going to try to hurry this up a little bit. The identification friend or foe is a system that closely relates to RFID in the sense that a control center or the ground center is beaconing a signal to nearby aircraft to identify them as a friend or foe. So an aircraft flying by will get a challenge response from the control center, and if they answer correctly, then what will happen is obviously the control center will know that they are a friend, and if they don't answer, if they give the incorrect answer, then they are a foe. How does this relate to electronic security systems? Well, as I said before, it's pretty much closely related to the RFID systems and how they work. First party, until something appears, initially the first party is in standby until something appears on the radar and then reacts. This happens in the same as RFID. What happens is there's a reader, kind of like this one, that's usually mounted in buildings near door and access ways. And what it does is it sits in a standby mode with this red light right here until a tag or transponder is within the near field range, which I'll talk about in a minute. But once that tag hits the RFID reader range, what happens is they kind of sends a challenge response, and the tag will actually let the reader know whether or not that it's, it should be there. So, what kind of companies are trusting these new electronic systems? While they're not used in the same regard as like building access control like HID systems, the number one RFID pretty much contributor and users in the States I know are Walmart and the United States Department of Defense. I'm not sure if you guys have Walmart over here, but they're pretty much a giant conglomerate in the States that, they have a lot of pulling power, especially when it comes to technology. So, what they did was these two corporations pretty much gave their suppliers a date on when they could, like a finalized date on when they need to have all of their inventory shipped using RFID tags. So they pretty much didn't have a choice on the matter. And then after that, pretty much RFID became a lot more prevalent, and a lot of the other retailers starting using RFID tags as well. So like Best Buy, Target, are the ones you guys have around here. A lot of these other technologies are being used all over the world. The e-passports, I know the States has the RFID reader, and I've seen a couple other ones this past week that have them as well. They all go by a global standard. So if one gets hacked, they all get hacked. The standard's the International Civil Aviation Organization. 10? Okay. All right, I have about 9 minutes to finish this up. So, basically, a person in Germany has already been able to clone the e-passports. So it's not the greatest technology. The second technology is being used now is microchipping. I don't know if you guys have heard of it, but in the States, there's pretty big usage in microchipping, implanting RFID transponders into pets. It gives them a a way to track the pets in case they get lost, in case their leash comes off. You know, my cat usually just takes it off the first thing she does. So national IDs are another way that this technology is being used. I've seen some this past week too. They usually hold a lot more information, a lot more authentication and security through encryption as opposed to the RFID cards. But this technology usually houses like biometric information, fingerprints, or facial recognition with the actual cards, since they have a lot more storage capacity than the RFID counterparts. Laptop and thumb drives adding biometric functionality. This ThinkPad right here has a fingerprint scanner. So thumb drives are now adding fingerprint scanners as like a secondary technology for security. Nokia NFC is something I just saw actually in Korea. There's phones that are now being manufactured, and this is pretty much on a wide scale, that have RFID chips. Now there's only really one reason why phones need RFID chips, and that's to create like a medium with the cell phone and carriers when you go to buy things. So they're thinking they're going to start adding, like when you go to the metro, you'll have an RFID reader, but instead of swiping or getting like a touch and go card, you'll use your phone. So they want to create this medium where they're pretty much used heavily as opposed to some of the other technologies out there. And then the last one would be HID Systems, which is a pretty big company owned by Assa Abloy, which we've been talking today a lot about. And these are like a higher security type of RFID and smart card technology. These are being used in government, healthcare, retail, industrial, commercial, airports, financial, educational institutions, to name a few. That's straight from their website. So, but HID systems are, you know, as you'll see, I don't have too much on here now, but if you guys Google them, you'll see that they're a little more secure than some of these other technologies. RFID is pretty much just an automatic identification. What it does is it stores and remotely retrieves data using tags. So over here in the corner, I have a passive tag, and basically the copper outer lining is the entire antenna. And inside the little dot is the IC, the integrated circuit, with a couple other electrical components. I'll talk a little bit about them in a minute. Two main parts of the RFID tag, as I just mentioned, the IC and the antenna. And then there's three, there used to be two, but another type of tag has been pretty much getting a little more popular recently, which is the semi-passive tag. The passive tag, as you just saw previously, has no internal power, which means it is not powered by a battery. It is powered by what's called near field. And if there's any radio enthusiasts or anyone who knows about a lot of EMF, what it is basically it's how the EMF on the reader has such a power that it has a near field communications, which means there's a certain degree of area where there's enough power within that field to power the passive tag remotely. It doesn't need to be even touching the RFID reader. And to get the distance that you would need on the RFID tag, there's a simple equation, which is the wavelength divided by 2 times pi. So the wavelength of a 13.56 megahertz tag, which is one of the most commonly used tags, is 22. And then you divide that by 6.28, which is 2 times pi, obviously, and you get 3.5 meters. So 3.5 meters is the distance that you could possibly have this near field communication with the passive tag. So that's the distance it needs to be activated by the reader. The second tag we have is the active tag. This one has self-sustained power to the IC and the antenna. So obviously the distance on the active tag is a lot greater than the passive tag. The last one, which is pretty recent, they just started creating, is a semi-passive tag. Obviously, by the name you could tell it's power supplied to the IC only, and then the antenna is similar to the passive tag. This is just a quick chart showing the differences between active and passive. The information is going to be online. I'll give you guys a link if you want at the village if you need any. This is basic architecture of two different systems, one using the active tag and one using the passive tag. If you see the circular, this concentric dotted line here, this is the near field communication I was just talking about. The antenna is what's causing the near field communication, and if you see the passive tag, it has to be within that diameter. The active tag, being powered internally by its own battery, can be at a greater distance. It's also a good time to point out that the middleware here, which is what I added, basically you have 4 main points to like an RFID system. You have backend database, you have middleware, reader, or 5, antenna, and a tag, either passive or active. The backend database is obvious. It stores information of the RFID and customer and account information associated with that tag. The middleware controls, it's software that controls the reader and the tag's information. So there are 3 different bands which RFID is currently using. The low frequency, high frequency, and ultra high frequency. The high frequency is probably the most common, sitting at 13.56 megahertz. The rest are used, but not as much. The frequency is a pretty main factor when you're choosing RFID cards because they have 3 distinct effects: the distance of the signal, the propagation of the signal, and the physical size of the tag. If you've seen the antenna on the passive tags, they're a lot larger than they really need to be. I'm going to try to skip some of this stuff. I have 2 minutes here. So the electronic product code is basically the equivalent to the UPC. Everyone knows the UPC barcodes. I'm pretty sure they use them here too. They use them in the States anyway. Basically what it does is it's been a system implemented to carry on manufacturing and item identification within wide sorts of stores and grocery stores and stuff like that. So the RFID equivalent is the electronic product code. What it does is the standard is GID 96, and it uses 96 bits of data. And the data is easily separated. As you see here, it's 28 bits of identifying the manufacturer. So we have 24 bits to identify product specification. We have 36-bit serial number. This is the unique identification of the object. And then 8 bits EPC header. The 8-bit EPC header is actually something that creates a bigger uniqueness to the EPC. It's just added to give it a more strength of security. These are 2 values in which I compared UPC versus the EPC. One of the disadvantages of UPC is it only had about 10 million variations, or 10 billion variations that you could use. But you could see with the 96 bits that I just talked about, EPC runs in a number that I really don't care of saying. It's a power of 9 magnitude or something. So if you guys want to figure that out real quick, good luck. The information in the values is by a book called RFID Security by Frank Thornton. If you're interested in any of the RFID security stuff, I highly suggest picking it up. It's by Singris. You can get it on Amazon. But the security of the RFID tags, and I have 17 seconds, is situated by ISO 14443, which is pretty common standard. They use triple DES and SHA-1, which are 2 encryption and algorithm schemes operating on the 1356 megahertz frequencies, which are pretty much the most prevalent tags. I'll just go over attacking RFID pretty quickly, and then I think I have to be done.
Sorry, we're rushing because I know we're supposed to end at 6. We're rushing for 15 minutes earlier because the Deputy Prime Minister is coming to the hotel and the bomb squad needs to clear the hotel 15 minutes before. So If we could take questions at the booth, because Lockpicking Village is on at the display for tomorrow, the whole day. So appreciate if we could take questions there. So I'll let. We'll do the pricing at the booth as well for the best questions tomorrow. Thank you. We'll let you continue for.
All right, I'm just going to go through a couple more slides and then I'll be done. What I'm going to be talking about really quickly is probably why you guys came here to a security convention, is attacking RFID. The first thing you want to think about when attacking RFID is the vulnerability objective. Is your objective actually obtaining a single item, corrupting the user database of the store or whatever target you'll be in, or something along those lines? So it has a major impact on what kind of method of attack you'll be using. One of the things I talk about is the electronic pickpocket. In New York City or some of the major cities, you'll see people, usually going around bumping into people, picking out their wallets. But now you really don't have to. The next level of that would be the electronic pickpocket. So I could walk around the city with, say, a HID cloner or an RFID cloner and just brush by these people and copy business card information that is pretty important. With that, you could obviously access some important areas. The 5 main attacks that I'll go, I'm just going to state. If you guys want to go through these at the village, I'll be there. I don't have too much time, but over-the-air attacks are spoofing, insert, replay, and denial of service. Spoofing is basically just changing the data bits on the card as opposed to what the reader thinks it's supposed to accept. You give it something different. Insert is the same thing as like a SQL injection command. Instead of numeric value bits, what you're doing is you're adding like a SQL command line into the bits because the readers don't really check for like a varying length. So they're not going to check that the SQL commands say, a couple, like 50 bits longer than it should be. So the command is injected into the reader and then therefore goes back to the backend database, which we saw through the architecture. And it could result, obviously, in some bad things. Replay attack is basically what you're doing is you're copying information from one card and you're cloning it onto another and replaying the data onto the readers. So basically, it's like if someone walks through a access door, you already read their information and you copy their information and use the same thing and go right through. The last one is denial of service or RF jamming. What it does is, obviously, if anyone used an RF jammer, it takes a large value and amount of data that shouldn't be on that frequency, and it pretty much go through biometrics. This is gonna end. If you guys want to talk any more about RFID stuff, I brought some stuff with me if you guys want to play around at the village. But I thank you guys again for being here, and we will be around this week.
We'll be at the village.
We'd like to thank Vivian. We'd like to